Assalamualaikum warahmatullahi taala wabarakatuh and good morning to all. Alhamdulillah, syukur kepada Allah. So with his blessing dapat kita jumpa pada pagi ni, and would like to thank all of you again for having and sparing your valuable time attending this knowledge sharing session organised by Pusat Jaringan Industri dan Masyarakat Universiti Teknikal Malaysia Melaka. I would like to give a special thanks to Mr. Ahmad Hafiz and his team for organizing this special event for this morning. So I hope everyone is in good health, okay, especially in this time of challenge, okay, and I hope the sharing session will be very beneficial to you to aid in whatever tasks or activities you are going to do or presently doing now. Yeah. Okay. So I will start sharing the slides. Before I start, boleh saya tahu ataupun maybe the participant would share dari mana organisasi bekerja sekarang. Maybe from the chats at least saya ada some indication lah and can gauge the expectation from all the participants. Maybe have a quick write up on the chat box maybe, ataupun nak onkan mic pun boleh. Nak tahu juga daripada mana kan. At least saya tahu ada seorang ni dia alumni of mine TS Muhammad Falik he's from UCSI University Kuala Lumpur. So terima kasih TS Muhammad Falik for joining in. Okay, terima kasih banyak Cik Hanif daripada Konika. Baik. Oh, okay. Cik Noradila, Teaching Factory UTeM saya. Okay, terima kasih banyak. Saya pun ada juga nampak macam IFMY, ada macam abbreviation di belakang nama tu.
It's from Inventive, Doctor.
Yeah, hello, good morning.
Hi, good
Dr.
morning.
Rizwan.
Hi,
My name is
Mr. Tai.
TK from Inventive Malacca. Yes, you see a lot of IFMY abbreviation.
Yeah.
Those are colleagues from Inventive Malacca because
Inventive
we
Malacca,
send the invitation to all our staff. Yeah, those who can join to join. Yeah, thank you.
I see. Okay, thank you very much, Mr. Tai. So IF Infineon MY Malaysia Melaka, I think. Yeah.
Yes, correct.
Yeah, right. Thank you very much for attending. So okay, thank you very much, Nurul Atika. Okay. Oh, okay. Intern student from Teaching Factory UTeM. And Mr. Azizi from Petronas Lubricant. Okay, welcome. Mr. Azizi attended the same training yang basic to mechanical engineering.
No. This is the first time I'm joining this session.
I see. Okay. Alright. Thank you. Welcome, Mr. Azizi. So okay. So again, welcome to everyone. So I would like to start the session. Thank you. Okay. So then I will deliver the session. I think very casually. So mix Big M and BI is okay to everyone, and I highly appreciate if there's any question or comment along the way. So please do interrupt. Yeah. Okay, just to have a quick check from everyone, is the slide visible to you right now?
Yes, it is.
Okay, all right. Thank you very much. Okay. So, again, good morning and welcome to everyone. Okay. So, for today's this morning topic will be about inventive problem solving strategy using TRIZ method. I've managed to attend yesterday's sharing session organized by PGIM UTeM on similar topic yesterday, given by our TRIZ clique as well, Dr. Mai and Puan Isadora. And for today, I will share a little bit more. Okay, some of the contents are the same. be a good refreshment to all of you who have managed to attend the session yesterday, as well as I would like to give some case studies, okay, simple case studies on how actually this problem solving method can be applied, okay, in several occasions, okay. So just yalah, kalau tak kenal tu kita tak tahu kan. Okay, just a bit about me. So okay, my name is Muhammad Rizwan Mansur from Faculty of Mechanical Engineering, UTeM. So this is my almost 17th year serving UTeM as a lecturer. Previously I was attached in the NPI department, QA/QP NPI department. After graduating in 2001, so have couple of years in factory working experience before joining in UTeM. So alhamdulillah, I managed to complete my PhD in mechanical engineering in 2015, and my current research interest. So I am really interested in design for sustainability, as I'm attached with the automotive department since 2005. So I'm also involved in the automotive designs, and also I'm doing several research, okay, with my counterparts in UTeM and other IPTs on composite materials. So in terms of professional qualification, so alhamdulillah, I'm registered with the M board, okay, as well as I've been given the opportunity to go for several certification level, both from MyTRIZ Malaysia and MyTRIZ International. Okay, yes. So yes, that's a little bit about me. Okay. Okay, so the webinar contents is about TRIZ method. So definitely the first thing that would come across for me during my first day of learning about TRIZ is, what is TRIZ actually? And when we talk about TRIZ, there's always a continuing keywords being repeated again and again about inventive problems. So what's going on between TRIZ and inventive problems? And then definitely we would like to know how TRIZ works, and what are the advantages of TRIZ. And then we would like to, I would like to share a little bit one special terminology related to TRIZ, which is the ideal solution. So this is what fascinates me about TRIZ method. Okay, I know there are a lot of problem-solving method. I'm definitely aware that you have been exposed either theoretically or practically about various problem-solving method. Each countries have their own approach. So I think for US-based companies, uh, they are definitely going into problem-solving method such as design thinking, or for manufacturing process, there will be a Six Sigma, okay, the MAIC approach. And for the Japanese, definitely they are very proud of their lean approach in problem solving. Okay, there are many tools and about TRIZ. So the a quick revision. It is from Russia, and what this methods focus on is towards the ideal solution. Okay, the ideal solution. And later I will share a little bit of application on the TRIZ for inventive problem solving, both for root cause problem identification as well as solution generation. And if time permits, maybe we can have one hands-on activity just to gauge the understanding for all by all participants. Okay. So at the end of the webinar, I hope that all participants will be able to at least understand what is the concept of TRIZ, and have a basic capability in applying TRIZ method to for inventive problem solving. So I start with again, what is TRIZ? So definitely, if you attend all the TRIZ webinar, formal training, etc., so you will start with the definition of the method itself. So it's derived from the Russian says Teoria Ricenia isobretatarsik Zadach. Pardon me for the pronunciation, although until now I still cannot pronounce it very well, okay, in Russian, but definitely in English it's translated to theory of inventive problem solving. Theory of inventive problem solving. So the inventive problem is the main keyword that differentiates between this method and other problem solving method. So it's a multi-purpose tool, okay. So it's a problem solving tool, analysis tool, as well as a forecasting tool. So it's a multi-purpose tool, okay, for problem solving and for problem solving method. The inventor was the late Genrich R. Schuler, okay. The method started from 1940s in Russia, okay. After the Russian bloc collapsed, then the method were widely spread across the world, especially to the US, where many of the Ashula's anak didik okay, migrated to US and practice atau disseminate the knowledge of trees there. So it is created by Heinrich Schuler based on the study of invention patterns, okay, from the global pattern literature. So if you could Google, okay, if you have Google about Heinrich Schuler, so you can see that he's a Russian pattern engineer serving with the Russian government, and during his work, when he analyzed or studied all the patents submitted, okay, to the patent office, he could see that there's a trend, okay, a similar trend reoccurring, whereby all the patents submitted, okay, not all the patents submitted, but many of the patents submitted use use the same principles of solution, okay, to solve the problem. Okay, so that's what interested him, and then he studied that further, and and later he developed a set of 40 inventive principles to represent all the um, repeating inventions in all the patents. So dia ada a pool of patents. Bila dia buat search, dia dapat tahu many of the patents use the same or repeating principle of solution. And then when he analyze further, they group all the repeating solution tu into 40 elements ataupun 40 ciri-ciri that we will look further after this. So that's how the method started. And next is, what is an inventive problem? So as I said, the terminology itself, theory of inventive problem solving. So what it means by inventive problem, it is that this method deals the best with problem that encompass contradiction. So that's the another keyword which is important about TRIZ. Problem with contradiction. What does problem with contradiction means? Okay. Okay. So it means that a problem, it means that when you take a solution to solve a problem, that solution will create another another problem. Bila kita selesaikan satu masalah, that solution that we implement will create another problem. And definitely under conventional design process or normal solution approach, we will resolve to a trade-off. Okay, if that compounding problem arise, then we think we cannot solve it, then apa yang kita buat, kita trade off lah. So kita okay lah, adil lah, kita terpaksa sacrifice on something lah kan. And that is what TRIZ would like to focus on, to eliminate all the trade-off and strike to the ideal solution. Jadi TRIZ kata we can solve the problem by eliminating the trade-off. Actually, the problem can be solved without having to recite or end with trade-off. And when we is capable to do that, we will achieve what is TRIZ call the ideal solution, solution yang apa, ideal, sempurna macam tu. Okay. So these are among the trade-off that normally occurred. We like something to be strong, but we have to recite or we have to accept that it must be heavy. Satu yang kuat mestilah berat. Okay. But definitely for certain application, we would like it to be strong, but in the same time very light as well. Contohnya macam saya dalam bidang otomotif, towards the emission regulation, okay, by 2030, 2050. So vehicle lightweight is a strong emphasis for all automotive manufacturers, but we do not want to sacrifice on the structural strength of the component ataupun on the vehicle. We want the component or the vehicle to be strong, okay, to handle all the load, especially during crash situation. But at the same time, the vehicle is very light, okay, so that it consumes very less fuel. Less fuel means less emission, and that's very good in terms of cost as well as the environmental results later on. Another type of trade-off, okay, is that something must be effective, but definitely it should be complex. Kita nak something very effective, but kita terpaksa dapatkan solution yang very complex to do it. Or we want something to be fast, but we have to accept that it will use very high energy. So can we have something very fast, okay, but use very low energy? That's what we want, ataupun the ideal solution. Okay. Another example, we want it to be large, but due to that, we need to sacrifice on requiring a big space, okay, to accommodate all the area. Can it be large during the time that we like to use it, and can it be shrink or reduced when we are not going to use it? Boleh tak dia berada dalam keadaan yang besar bila kita perlukan, dan bila kita tak perlukan dia boleh jadi kecil aja. Is there any solution for that? How TRIZ works? So there's 4 steps in TRIZ, the approach. First, but if you can see kalau kita tengok all problem solving methods more or less use the same principle of the approach. First, we need to define the problem. Okay, definitely to solve the problem, we need to define the problem, especially the root cause of the problem. And for that, TRIZ divide the problem into 2. First, we define the specific problem. Okay. Later on, okay, we generalize the problem. Kita tukarkan dia kepada ayat-ayat lebih mudah untuk dipahami. Okay, ada sebabnya. Okay, nanti saya akan jelaskan. Okay, and then from that general problem, we use set of TRIZ tools ataupun database to come out with a general solution. Okay, so it's TRIZ ada dia punya methodology dan ada dia punya algorithm whereby we can find the general solution to solve the general problem. By that general solution, later on, kita sebagai the user, okay, can use the general solution as a guide to expand it and develop it to our specific needs. Okay, so later on kita akan develop the specific solution. Okay, and from that specific solution, definitely it will solve the specific problem originally in hand. So that's how it's worked. Okay, so definitely first define the problem, later on define the solution, but within the problem definition and solution development, so we have specific and general. Okay, so that's how TRIZ works. Several advantages of TRIZ. Okay, first, to break the psychological inertia to be creative and innovative. Okay, so as Ashilid said, actually people have the capability to be creative and innovative, especially in solving problems. But then one of the limitation is the psychological barrier. Kita ada some psychological barrier yang mana kita jadikan dia sebagai apa alasan untuk kita tak dapat to be creative atau inovatif. So please cuba cari jalan how to break that psychological inertia by having specific method, okay, to do that. It can be used either individual or by a team, and definitely it has been proven capable to solve inventive problem either by individual or through a team approach. It can predict trends of product system evolution, okay, and solve problem based on the product atau process function. Okay, so dia TRIZ, dia solve the problem by focusing on the function of the product or process. Sebab apa? Ada satu ayat kat sini. Product change but function remain. So dalam TRIZ, dia kata produk sentiasa berubah-ubah. Okay. Kalau kita tengok phone kita, handphone kita makin berubah-ubah. Ataupun kalau kita tengok dalam printer, okay. Kalau kita tengok printer pun berubah-ubah. Tapi the function of all the product remain the same. It's just how ataupun in what shape aja. So by focusing on the function, then we can solve the root cause of the problem. Okay. And definitely why I take very strong interest about TRIZ is that ada banyak method of the problem solving, and by accumulating more methods, okay, to our rack of knowledge, kan, we can have the right tool to do the right job. Itu yang penting, so we can optimize and be productive about that. So when we come into problem solving punya situation, so we have the set of tools that we can use. Okay. So definitely saya pun tak kata TRIZ is the ultimate tools to solve everything. Okay, I don't think that's to the extent lah. But later on, kalau kita go further into TRIZ, then we know at what situation TRIZ is very advantageous compared to others, and also at several situations we can see some limitation of the TRIZ compared to others. Macam tu. But definitely we will want to know more so that we can have the right tool to solve the right job. Okay, and for this case is to solve the problem. So going towards the ideal solution, so kalau based on the governing equation, ideal solution means the sum of useful function over the sum of cost plus the harmful function. Ini kalau kita tengok dalam value engineering pun dia lebih kurang pakai filosofi yang sama. All the plus divided by all the minus or all the cost. So when we can have all the values higher and higher, while in the same time reducing all the costs or all the unwanted function, then we can strike to the stage to have the ideal solution. Okay, in the later on. Example of TRIZ ideality concept. Okay, ni tak apa kalau kita tak dapat nak accumulate on the method itself deeply, at least kita faham what is the main concept of TRIZ. Okay, one example of the ideality concept is, okay, is there any solution? The best taxi with no taxi. Ada tak? We want a taxi, okay, but without the form of a taxi, ataupun without the conventional form of taxi. Ada sesiapa yang nak cuba bagi suggestion?
Grab.
Oh, okay, thank you. Right. So Grab is not a taxi, okay, but then it owns boleh kata many all the car drivers, okay, are attached with Grab. Okay. So the best hotel with no hotel? So for me, I would like to take Airbnb as the example. Okay. Of course, definitely ada banyak lagi solution provider yang sama. But the main thing is it can provide the function of a hotel without having any physical hotel by itself. Okay, so the function on the top side of the equation is high, while in the same time on the bottom side of the equation it can Airbnb can reduce all the costs or all the unwanted function. So it push the value very high towards the ideality. And just to have everyone attention, is there a best printer with no physical printer? Ada tak current solution, something that can function as a printer but actually it's not a printer?
In the office, we use photocopy machine, but included as a printer as well.
Yep, agree. Yep. So, but then we can see that the solution carrier evolve from a dedicated printer into a multi-functional equipment that can print. So we cannot call it a single printer anymore. Then kita boleh kata um, a multi-purpose document manager or something like that. Yeah. But thank you for the example that we can see the function remains the same, but then the form, the carrier of the function tu dah mula berubah-ubah. So that's what the ideality in the trees would like to go to. So we would like to stay the function, okay, ataupun keep the function. And what is the best form that can perform the function? Okay, towards having to strike the ideality. Okay, so actually dalam trees ni dia ada banyak set of sub tools untuk digunakan. So, okay, so saya petik ni daripada buku daripada My Trees Malaysia, okay, version 2009. So on the first stage, to define the problem root cause, dia ada tools, okay, dia namakan function analysis, cause and effect chain analysis. And then bila kita dah define the problem, how do we model the problem, and how do we model the solution? Dia ada banyak pilihan pula yang kita boleh gunakan. Among them is the basic is the trimming tools, okay, to solve the problem. And then we have the engineering contradiction with inventive principles, physical contradiction, function model, kemudian kita ada substance field model, and finally ARIS ataupun algorithm of inventive problem solving. So these are the tools that we can choose to solve problems. So one problem can be solved either by taking engineering contradiction approach, ataupun physical contradiction approach, ataupun substance field approach, ataupun ARIS approach. So that's the advantage lah. Okay. So by having that, actually the important thing based on my experience lah kan, in problem solving is that we can have as much as solution as possible, so that later on we can analyze which solution is the most appropriate based on the constraint that we have or the resources that we have to solve the problem. So it tries to to spur all the ideas by having by using different set of tools. For root cause of problem, okay, identification. So there are two steps, okay. First is to perform function analysis and second is to perform cause and effect chain analysis. Ini perkataan yang terminologi yang digunakan dalam TRIZ. So dalam root cause problem identification ni dia ada dua step, okay. Okay, first is to perform function analysis. So dalam function analysis tu dalam TRIZ dia ajar first is to identify our engineering system, okay, and then define what is super system and what is the subsystem, okay, related to our product. So super system means what are the environmental condition that interact with our engineering system. Dalam case ni, kita ambil engineering system is the bicycle. Okay, and the subsystem, what are the sub-component attached ataupun related to the engineering system, main engineering system ataupun the main assembly. Okay, so we have all the subsystem or sub-component such as the chassis, the brake, okay, the gears, etc. So first we need to identify what are the components, okay, then we can see what is different about TRIZ to the other method is that it also includes the component of the super system into the to define the engineering system. Okay. Alright, and then because this focus on the function and then to identify the problem. Okay, so the next step is to perform the function analysis. Jadi for the basic is that on the left side ni is the subject and the right side is the object. So linking between the two is the function. Okay, gitu. So function is what change the object parameter. Okay, and contohnya macam tadi, okay, people, okay, subjeknya contohnya orang, okay, objeknya adalah basikal. So what is the function of the people to the bicycle? Okay, ataupun okay, in the other way around, okay, the subject is the bicycle and the object is the people. So the bicycle, what is the main function of the bicycle is to move the people. Okay, so dia menggerakkan penunggangnya. Okay, and normally what hindered problem solving method is the definition, okay, that we use to define the problem is too technical. Okay, yang mana kadang-kadang nak memahamkan technical words itu sendiri pun menjadi satu isu kan. Okay, jadi TRIZ cuba to convert all the technical jargon tu into a much more simple words yang a layman pun boleh faham, sebab it will represent the basic function. Contohnya kalau dalam semicon industry, so we have the etching or polishing process. So what the process really do is to remove something. Okay, so etching by chemically remove, polishing by mechanically remove, but the main function is to remove. So grip is to hold. Okay, but sometimes people senang je nak faham grip, but sometimes people what is grip? Grip tu actually is to hold. Okay, drive is to move. So by converting all the technical jargon into a much more simple function definition, then kalau kita nak solve something or to try to understand the problem tu, they make it more easier. Okay. Okay, just a quick review. What is the main function of this product? So kita ada bottle, kita ada water dan juga kita ada meja. What is the function of the bottle to the water? Apakah fungsi bottle terhadap water? So for this, okay, the clue is the bottle holds the water. Okay, bottle tadi dia contain water. So kalau saya pakai contain, maybe slightly some would like to call it a higher technical words to describe the function, but we try to reduce it to more simple words. Bottle hold water. Okay. What is the purpose of ataupun the function of the cap to the water? Ada sesiapa nak share? So we have the bottle cap and the water. What is the function of the bottle cap to the water?
Prevent water from spill out.
Yeah, definitely. Tepat. So preventing the water from spilling out kan. And we can change that. Ada tak perkataan yang lebih asas yang kita boleh gunakan Is there any other basic words that we can represent the same thing? Saya bagi clue yang ni. Okay, between the three ni ada tak yang boleh represent the same function tadi to avoid the water from tumpah tadi? Yeah.
Maybe whole water.
Whole water. Okay, excellent. Alright. So that's the intention. Okay. Okay. What is the purpose of the table to the bottle? Apakah fungsi table terhadap bottle tadi? So, is there any suitable keyword ni yang boleh represent the function of the table to the bottle? So for me, the function of the table is to hold the bottle. So untuk untuk memegang ataupun untuk meletakkan botol tadi. Itu. Right. So by knowing the root words atau kata dasar tu tadi, and then kalau kita nak cuba cari solution, and then we try to focus on the root kata dasar tadi, the root words. Okay, what are the solution that can perform the root function tu? So that's the intention. Okay, and then when we define the main function, okay, kemudian kita boleh classify the function to its performance. So either the function is a useful function, insufficient function, excessive function ataupun harmful function. So dalam TRIZ, dia divide all the function into several categories based on the performance. Adakah function yang sedia ada tu berguna, tak cukup, terlalu lebih ataupun function yang memudaratkan. Okay. Sebagai contoh, a fruit gripper ni. So, okay, the grip holds the apple. Okay, itu main function of the grip. Grip holds the apple. Kalau dia bekerja dengan baik, okay, so kita bagi perkaitan ataupun kita lukis pada function model kita ni arrow yang seperti ni. Tapi jika dia tak sufficient, maknanya the grip insufficiently holds the apple. Apa yang berlaku adalah bila dia grip, maybe after 5 second buah tu akan jatuh. Sebelum 5 second okay, tapi after 5 second dia akan jatuh. So that's maybe the root cause of our problem. Okay, so kita classify dia sebagai insufficient or excessive. Kita pun boleh classify the same function as excessive. Bila dia grip tu, dia grip terlalu lebih. Dia tak adalah sampai pecah buah tu, tapi dia meninggalkan some sort of gripping marks pada permukaan dia yang tak cantik lah. Kalau kita tengok apple, asal ada macam cala-cala ni pada kulit dia kan, kita pun macam tak berminat nak belilah kan. So it can hold the apple but excessively. And finally harmful function lah. Ini maknanya dia grip, dia terus merosakkan buah tadi. Okay, so yang ni I think ada some of the problem solving methods pun guna the same approach, yang mana they link all the components okay between each other. Okay, and then between the component tu kita masukkan what is the main function, and then we categorize the performance of the function. Jika the performance tu harmful, dalam TRIZ dia letakkan arrow warna merah. Kalau excessive, a bold ataupun a heavier weight of line. Kalau insufficient, dia bagi dalam dotted line. So from there, okay, once kita dah buat mapping of the product function, we can identify all the root cause ataupun potential root cause. Dan kat situ kita boleh fokus to solve the problem. And to later on, okay, kita pun nak tahu what is the actual ataupun potential root cause of the problem tu based on the key target disadvantages yang kita dah identify tadi from the function analysis. So what we do is ask why lah. Saya rasa ni dalam Japanese problem solving method pun dia memang very focus on this. Tanyalah sampai minimum 5 kali lah, and then by the fifth answer tu kita know what is the root cause. So sama juga dalam TRIZ dia pun gunakan approach yang sama. Okay. Right. So kat situ okay. Next, after we have identified what is the root cause of the problem, then definitely kita nak go to the how do we solve ataupun find the potential solution. So saya tunjukkan tadi dia ada banyak approach yang kita boleh guna, tools yang kita boleh guna. Saya akan tunjukkan dua aja kat sini. First is the trimming tools, and secondly is the 40 inventive principles. Right? So trimming tools ni kalau kita tengok gambar ni, it speaks for itself. So to solve something, we can remove it from the whole picture. Kalau that something is causing problem, what we do is we remove it from the whole picture. Okay. So cuma dalam TRIZ, okay, dia bagi more guideline on how to do the trimming ataupun removing process of the undesired function. So definitely again, kita tengok what are the component involved. If the component is performing undesiredly, then we can trim ataupun remove that component. So, okay. So there are 3 trimming rules. First, trim the subject when the function is no longer required. Okay, trim the subject where the same function can be performed by the object itself, and trim the subject when the same function can be performed by other subject or super system. Maybe this diagram can be a better representative of the rules. So ni rules number 1. So kita boleh trim the subject okay. If the object of the function is trimmed. Okay. Rules B, okay, kita ada function carrier, we can trim the function carrier if the object can perform the function by itself. Jika objek kita tu boleh buat benda tu sendiri, tak perlulah ada objek lain yang buatkan kerja untuk dia. We can trim the other friend. Okay. And rule number C, okay, function carrier can be trimmed if another function carrier performs its useful function. Contohnya kita ada satu produk, okay, satu komponen, dan in order for that component to function, kita perlukan 2 komponen lain. Okay. Jika komponen yang kedua tu pun boleh menjalankan komponen yang fungsi yang sama dengan komponen satu, then kenapa kita perlu ada extra man to do job ataupun extra component to do job? So we can trim that one, okay, to optimize the process ataupun to solve the problem. Okay. Example, how do you trim a toothbrush? Okay, so we focus on the function. Okay, the function remains the same, but then we can, by trimming, we can have another look at how the solution will be. How do you trim a phone charger? Kalau isunya adalah wire yang dangling around, okay, so definitely we can remove the function of the wire, which is to carry the power, okay. And then we can use another method of power transmission, which is through wireless method. Okay. So the functions remain the same, but then how it works, tadi kita dah ubah dia. The second method is through the inventive principles. Inventive principles. So macam saya kata dalam awal-awal tadi, bila Ashula analyze all the pattern, dia nampak many of the pattern use repeating atau the same and repeating principle of solution, principle solution. So and lepas tu bila dia analyze lagi, dia classify them into 40 repeating inventive principles. Itu term dia. Yang mana balik-balik pattern gunakan idea yang sama aja nak solve the problem. Which is very fascinating juga lah sebab this is based on statistical analysis by Ashler. So how we do it, okay, dia ada apa algorithm ataupun method dia. First is to create an engineering contradiction statement, if then but, if the parameter, if correspond to the parameter to be improved, then is the positive change or condition that required, but is the parameter which will worsen or deteriorate due to the improvement made. Ini yang saya kata trade off tadi. Bila kita tukar sebab kita nak something, of course kita dapat dia. Tapi kita terpaksa pula sacrifice on something. Boleh tak kita solve the contradiction? So yes, we can solve it. Okay. First kita tukarkan, kita change the complex problem into a general problem using TRIZ 39 system parameters. Kemudian kita gunakan TRIZ contradiction metric. We use TRIZ contradiction metric to search for the general inventive principles. And later on, okay, we apply the general inventive principles to develop a more specific solution to solve the specific problem. Ini yang saya tunjukkan tadi, the flow chart tadi. Okay. So there are 39 system parameters. What the system parameters do is to convert the complex problem keyword into a more general problem keyword. Itu aja yang dia buat. Okay. Kemudian tadi kita dah from there we can based on the keyword, setiap keyword ni ada number dia. If you can see 1 until 39. Okay. So we know which keyword correspond to the things that we like, which keyword correspond to the ataupun the things that we have to recite to that we don't like. Benda yang kita terpaksa terima tapi kita tak suka by having the solution. So kita ada number tadi. So from that number kita use the TRIZ contradiction matrix. So the matrix ni actually until 40, until 39. Okay, 13 number ni until 39. Turun pun until 39. So yang on the left side is all the features to improve, and on the top side is all the undesirable ataupun feature that worsens by having that solution. So kita mapkan, okay, contohnya tadi, if the feature to improve is the weight, but we have to sacrifice on the length. So kita gunakan matrix ni, and kat sini dia ada bagi numbers. So this is the solution principles yang TRIZ cadangkan untuk gunakan. So what does number 15, 8, 29, 34 ni correspond to? Ini all the 40 inventive principles. 1 until 40. Okay. So kita ada segmentation. We can solve problem by segmentation. Kita boleh solve problem dengan memecahkan dia kepada bahagian-bahagian kecil. Number 2 ni more or less we can solve the problem by taking out one of the component or taking out the problem, the troublesome component. Okay, we can solve the problem by making something that function universality ataupun dia boleh buat multi-function. So this sort of general inventive problem keywords. Okay, ni in the graphical ways in representing all the inventive problems. Okay, so actually we can also skip the matrix process by directly going to the inventive principles in aiding us to find ideas how we can solve the problem. Tadi kita dah identify what is the problem. Kemudian untuk determine the solution, kita boleh check either 1 until 40 ada tak either one or some of the principles yang kita boleh take as an idea to generate the solution. So that's another way of using the inventive principles. Okay. Saya bagi satu contoh, okay, within this last minutes. A workshop acquire a heavy duty working table for its production. The table is strong and can hold very heavy load during operation. So that is what we want. However, the downside is that it requires many workers to move it when they want to change the location of the table. Ini masalahnya. Bila kita nak tukar setup line etc., kita terpaksa spend lot of resources lah, kena cari mesin untuk angkat dan sebagainya. So is there any idea that we can solve the problem okay, quickly? So just go through. So step number 1, okay, kita define the problem okay, based on the TRIZ punya recommendation. So we like to know what is the contradiction that exists, apa yang berlaku, contradiction berlaku. So if the table is heavy, this is the desirable parameter, then it will be strong. So itu yang kita nak, but then it is difficult to move. So that's the undesirable parameter. And then we match the high technical jargon tadi to much more simple keywords based on the 39 system parameters yang ditunjukkan sebelum ni. So heavy correspond to the weight of the stationary object. Number 2, difficult to move. Bagi saya mapkan dia to ease of operation. Okay. So from there saya apply the contradiction matrix. So saya tengok number 2 on the feature to improve and number 33 on the undesirable result. Dan these okay, number 6, 13, 1 and 32 are all the potential inventive principles that I can use to solve the problem. Nanti dia ada definition for all the principles, then as a designer saya akan fahamkan and then saya akan cuba relatekan dengan apa specific solution yang saya boleh buat. Okay, so these are some of the ideas. If I use solution, principle number 1 is segmentation. So I can apply the principle by solving the problem through making the table component to be easily disassembled and then reassemble at the desired location. So dia berat, tapi saya jadikan dia senang untuk dibuka dan dipasang. Jadi anytime saya nak move, saya boleh buka dia dengan cepat dan letak di new location dan pasang dia. So that's the principle of segmentation. And then principles of 13, the other way around. So instead of the saya boleh apply the solution whereby the worker push the table to the desired location by the aid of a roller placed alongside the moving path. So saya boleh letakkan some sort of roller, okay, under the table, okay, along the moving path. Jadi saya boleh gerakkan dia dengan mudah. So saya some sort like ada moving line lah. Or I can also use the principle of dynamics. Okay, I can install a caster wheel, okay, on the table legs for easy movement. So saya dah build in a caster wheel. So anytime walaupun dia berat, saya boleh gunakan the wheel, okay, to move the table around. Okay. So maybe yang ini saya nak tunjuk satu video, okay. Kejap aja. Boleh nampak videonya?
Belum lagi, Doktor.
Oh, belum lagi? Cik Hafiz, boleh nampak?
Tak keluar, Doktor.
Tak keluar
Ha.
Okey. Tak apa. Okey. Masih keluar yang PowerPoint tadi
Masih keluar yang PowerPoint.
Okey, tak apa. Okey, later on saya tunjukkan dia. Dan ini just a hands-on activity lah. Right. Okey. Kalau siapa yang berminat nak slide ni, just boleh masukkan nama, email dekat feedback form tu lah, nanti insyaAllah saya share nanti. So that's all. So siapa yang berminat untuk go further into TRIZ, kita ada My TRIZ Association. So dia ada all the different levels of training towards the actually level of training tu correspond to the tools. So dia tak dapat nak ajar all the tools in one training, dia divide into several training program lah. So each training program tu dia akan ajar several set of tools from basic to advanced. Dan di UTeM pun kita pun ada our TRIZ team. Okay, kalau siapa berminat ataupun ada apa-apa nak tanya sebagainya, boleh contact lah either one okay, of us. Okay, through the email. Okay. And kita pun ada our Facebook page jugalah. So regularly Kalau ada apa-apa aktiviti, kalau berminat nak join, kita akan share through the Facebook page. Okay. So I think that's all.